Question 5 is coming from transformations of functions. In the diagram, the graph y is equal to f of x is shown with solid lines. This one here, the graph shown with broken lines is a transformation of y is equal to f of x. Part A, describe fully the two single transformations of y is equal to f of x that have been combined to give the resulting transformation. Now, what we are going to do here is to look at the points and then the corresponding image. Okay, so let's say we are looking at this point here and the corresponding image is here. So this one was transformed up to that. So let's look at what is happening here. So this coordinate here is, I think this is 0.5 and 1, not so? 0.5 and 1. Now I'm going to have 0.5, then 1. Then another one is this point here is 0, 2. Okay? 0, 2. Now, this other one is 2, 2. Now, let us look at the corresponding points in the image. So this one here is 4.5 and 3. So I have 4.5 and 3. Then this one here is 4, 6. Remember, this one corresponds to this one. It's the image point of this one. So that's why I'm putting them below. So we are going to have 4, then 6. And then the one that corresponds to this one is 6, then 6. 6, and then 6. Now, let us look at the x coordinates. What is happening to them? If this is 0.5 and this is 4.5, what was done there? I think they added a 4, right? Is it the same thing to this one, 0 plus 4? Is it the same thing to this one, 2 plus 4? Then the y coordinates, let's see what is happening to the y. 1 to 3, 2 to 6, then 2 to 6. Did they add a 2? But then when you add a 2 here, this one goes to 4. So it wasn't that. Now, what if we say they multiplied by 3? And also here, 2 times 3, you get a 6 times 3. So that is that. Now, we are seeing an addition. In the previous videos, I've always talked about when it is addition or subtraction, that is a translation. If it is multiplication, either on the x or on the y, that is a stretch. Then the change of the sign, it is reflection. Now, we are seeing an addition. So we are going to have translation by vector. So the x coordinates, they added 4. That will be 4, 0. Okay. And then when we look at what happened to the y, they multiplied by 3. So I will say stretch by factor, or we can say stretch by scale factor, 3 parallel to y axis or in the y direction. So those are the two there. Then part B, state in terms of y, f, and x the equation of the graph shown with the broken lines. So using these two here, what do we have? I can have, remember, y is equal to f of x. That is where we are starting from. Maybe y1 after the translation, we will have, remember, when it is moving away from here and it is written in the function here, it changes the sign. Okay. For example, I have my graph here. Suppose we have y is equal to, let's say, x squared. That is the one there. Okay. And then we get y is equal to, I'm transforming this, so x, let's say minus 4. Okay, minus 4. Then I close the brackets and then I square. Do you see that it has shifted to the right by 4 units? Okay, the blue one, it has shifted to the right by 4 units. But inside here, remember the translation here is going to be, because it has moved to the right, that is 40. You see that? But when I'm writing this one in the function here, now it comes here as a minus. If we put, let's say a plus here, it is going to move to the left. So if we put a plus here, do you see that it has moved to the left? So that means the translation here is going to be minus 40. So when this one is popping out, it comes into the translation vector as a negative. You see that? So when we come back to this one here, we are going to have f of x minus 4 after this translation. Okay? Then y2 is going to be stretch. We are multiplying. It is just a multiplication. So 3 into this one here. You see, in my chapter summaries here, I have in functions here for transformations. So, sorry. I want you to look at the stretch. If we are getting the function and we are multiplying it by a scale factor, so that is a stretch, a factor a parallel to y-axis. Again here, if we are getting x and we are multiplying it by a, then it is a stretch by factor 1 over a. So for this case, since it was a stretch in the y direction, then we just multiply all through by that 3. Okay? So this is what we are having here. So therefore, the new equation of the graph, or the equation of the transformed graph, is going to be y is equal to 3, then f of x minus 4. This would be our final answer.